I'm still looking for a fault, because I did replace the electrolytic capacitor, which was this one. Oh damn it, I can't get it on. Where am I? This is trouble when you're zoomed in, you can't see where you are. Right, so this capacitor, I replaced that one, right, because it was giving me funny readings, but I since found out that it might have been my leads. You know, them stupid, horrible Chinese leads. The ones that you get off eBay that the wires aren't soldered on, they're just crimped, and you have nothing but trouble trying to figure out what the hell's going on, and then you find out it's the crappy leads. And yeah, well, I had issues with the leads, and there was a coating of varnish on the circuit board, as you can see by that glaze, which is also another freaking annoyance, because when you're trying to make a good connection to electronic components, you get false readings, and it can throw you a curveball. So right now I am kind of up the creek, or down the creek, whichever you want to. I'm basically stumped right now, trying to figure out what the hell is going on with this thing, because everything seems to check out. Now, I also thought there was a short circuit on this diode down what was it, is this, let's see, where are we, I can't even see it, I have to look on that, 703, because this particular diode was giving me some very low readings, that one down here, but it's not short circuit, and it reads the same in both directions, and it looks like it's across a resistor actually, or an inductor. I don't think it's that, because well, you would be seeing smoke probably. I have no idea what these transistors are, and this freaking camera, Streamlabs disabled my ability to turn on my torch, and I can't find the function in Streamlabs to turn the torch on. Streamlabs, get your act together and let me turn my torch on my phone so I can see what I'm looking at. Right, so my phone, I was using the other the built-in camera function. I was able to turn my torch on, but I can't do it with Streamlabs. It won't let me turn the torch on, so this is what's really frustrating, because I need more light. I'm buggered if I'm going to have to get my other phone out just to, yeah, it's just silly. So at the moment I'm looking for ideas and suggestions if anyone wants to comment, because I can't find a problem. I've checked the resistors. Now the surface mount resistors, I've been going over some of these, checking some of these. Now the 33k resistors are fine, which is a 333. I don't think we need to worry about the 10 meg ones. There's a few 10 meg ones on here. These are tiny little things here, you know. I think the 10 meg. It's hard to see. Hang on, I can't get my glasses to focus. 105 looks like 10 meg to me. Pretty sure that's 10 meg. But anyway, they're reading pretty low. No surprises there, because there'll be leakage and there'll be a cost of the components on the board. But I don't suspect that those will be to blame for whatever's going on here. It's just a bit frustrating at the moment, because my eyes are bad, and I'm also having visual problems with my phone because not enough light, and I can't work on surface mount components anyway, because Well, let me just put it another way. If I was to try and unsolder one of them things, let me just show you something. Right, this is my soldering iron. See the size of my tip? I have got some tiny tips, right? But now if you look at that tip and you look at that resistor there, yeah, these things are so freaking tiny. Lewis Rossman on his YouTube channel, oh, he's lost loads of these things, yeah, especially with hot air, they blow away, you know, obviously. And my soldering iron would destroy these things, yeah. So there was one situation on my inverter, which I repaired recently, where I found an open circuit surface mount resistor. It was definitely an open circuit, right? And rather than pull it off the board, I just piggybacked a normal resistor onto the back of it, and I got that sorted out. I got that working again. But that's not always an option. I think it was something like 47 ohm or something silly. It was a power resistor. So I'm hoping that we're gonna. I'm hoping I can find the problem, but it's not looking up. I'm not very optimistic about it. So I'm having trouble reading this stuff. My eyes, I've got very focused on my glasses, right? Let's get this a bit closer. Let's see. There's these things are capacitors. These little brown ones without markings on. Those are generic capacitors, and they're freaking tiny, you know. Look at my meter probe. So yeah, I just if it's one of these things, I'm not even going to bother, because I can't take them off the board to check them, because I don't have a microscope and I don't have the tools to do that. I'm hoping it's just a power resistor or something, but let's see, what's that? Is that a diode? What's a diode? Oh, let's put it on diode mode. Oh shit, everything's falling out. Hang on a minute. Oh. I've got no room anywhere. Just a minute. This is what happens when you've got power supply batteries hooked up to your meter. You move one thing, everything else falls over. Trying to pick stuff up that I've just knocked over on the floor. My torch is gone somewhere. What's that? So you can't see what I'm doing, but it's nothing interesting. I'm just picking junk up I've just knocked on the floor. Now, where was I? I forgot what I was about to do now. It threw me a curveball. Threw me off. Right, oh, that diode. Right. I'm too freaking old to do this shit. Really am. Had enough. When I was 25, it was great. I could see everything. See what I was doing. And everything got small. I feel like Land of the Giants. I'm looking at the little people. Right, so this diode. We need to check these anyway. I keep knocking stuff over because... Right, what's this diode read? Not getting anything at the moment. Just a minute. Frigging wire. Right. My meter is definitely working, but I'm not getting a reading. Just a minute. D705. Are you a Xena diode? Are you a Xena diode? Hang on, that looks a bit suspicious. What's this on the side of this? Is it bleeding? No, it looks like some ink or something. Bit of red stuff on the side of it there. What the hell? You know, you have no idea what these businesses, companies that make this stuff are up to these days. I'm sure they're putting some weird shit on there. That is definitely a diode. It says D705. I am not getting a reading. So let me just check this. It might be because of the varnish. I am not getting nothing. I'm pressing into it and it's... Let's try the other way around. I might be the wrong way around. Ah, okay. I've got a reading 0.512. That looks quite normal. Sorry, you can't see the meter because I'm zoomed right in so you can see what I'm doing on the board. What's this one? Are you another? No, that's a coil. Oh, that's a coil. L707. These have been known to go open circuit. Right, let's go on to ohms. Oh, I made a mistake in the previous video. I was saying that I'm on diode mode when I was actually not. I was actually on ohms. I'm getting old. I make mistakes. I'm not perfect. Right, this is a coil and it's reading 0.9. Doesn't seem to be 0.7 that way around. Doesn't seem to be anything wrong with that. 0.6 now. What the hell? Mind you, I'm probably cleaning the varnish off. Well, when I put my meters probes together, I get 0.5. So there's basically 0.2 of an ohm across that coil. So it doesn't seem to be short circuit or anything. Now these semiconductors, I'm not sure if it's a MOSFET or a transistor, but I suspect it's a MOSFET. That's the most common thing nowadays. I haven't managed to get a reading off these at all. I need to be on diode mode. You can't really check these things out unless you take them out of the circuit. Put them in a component tester. I really want to get one. I need to get one of them newfangled computer. Oh right, we've got a reading. 0.512. So what is this? Is this a transistor or a bigger MOSFET? 0.525. It looks like a transistor. 0.525, 0.511, and over limit. So there doesn't seem to be a short with that. I assume that's the base if it's, or the gate. So right, so that's, which one's that one? That's the one that's on this heatsink. That's the we can't get a view on it. It's hard to see. Just a minute. Torch. That is, I can't read it. Hang on a minute. I need to pull up Mac mic. My preview. Oh, I can see it on the computer now. Right, that's better. Right, so it makes it easier for me to see what I'm looking at. So it's a 9R500C, and that doesn't appear to be shorted out or open circuit. Look at the freaking writing on the base. PCB, it's all in Chinese, you can't even read it. I mean, I don't know if it's base, collector or emitter because it's in Chinese. Give me a break. Do it in English. Look, these freaking semiconductors are in English. So make the circuit board listings in English too, please. We can't understand Chinese. Oh, give me a break. Right, so that doesn't appear to be blown or anything. There's no cracks in it or anything. What else could there be? I think there's another one over here. Right. This other... Now this circuit works by sending feedback impulses back to the driver circuit. So if the actual output circuit is faulty, the part that starts the circuit, the oscillator, it sends a pulse to start it once you press the power button apparently. But if it no longer receives any more pulses from the output stage, it will shut off because it's a protection. It's to prevent over voltage. Now let's see what this one is, if I can get in there. This is freaking hard to see. It's tucked right in there. I can't get the camera angle on it properly. Hang on, just a minute. I could take them out, but I'm not going to take them out unless I know there's a reason to taking them out. I'm trying to get the camera angle on it so I can read it. Let's see. It's very difficult to see what it is. RFN 20. Can't quite make out what's underneath. There's something in the way. T2D 61, or is it 6J? I can't. Freaking difficult to see. If I tilt it up more, it'll just block the view completely. Well, that's the other one. Anyway, that's the best I can do because the angles aren't there. Right, let's turn it over and see if this one, this one reads. And that's right there. That soldering looks a bit suspect. It's not very good. I might resolder that. It could be a dry joint on it. It looks, the middle pin looks a bit iffy. Right, let's try. Am I on the right thing? Yeah, I think so. Oh, yeah. Right, what are we reading? Oh! Oh! That's not good. I'm getting 0. I think I was. We got a friggin' short here. We have a friggin' short circuit. Maybe. I'm getting 0, 0, 0. This direction, this one is, oh, it's climbing. It's charging capacitor up somewhere. I have to wait for it to finish charging the capacitor up. I'm on diode mode still. It's reading 1. It's settled down 1.104. This might have to come out to check it properly. I definitely have to get that smart meter because it will make it easier to. I don't know what they've got. This smart meter is supposed to be able to recognise components, what they are, if you don't know what they are, and it actually tells you what they are, which is really useful. Which is why I want to get one. So, because I am old school, there's so many new components come out on the market now. A lot of stuff I don't know. A lot of stuff I think. You know, new inventions, new freaking. Anyway, so I was getting a short between what looks like base and emitter, or it could be gate and source. What's the other way around? I'm also getting 0, 0, 0. So that looks like a dead short between this end and that. Yeah, it could be a coil across it though, an inductor. But that's way. Oh, let me go to ohms a minute, because diode will always give you a much lower reading than what you do on ohms. So let's see what the ohms reading is for this. I am getting 0.6, and if I short my meter together, it's 0.5. Oh no, it's 0.6. I've still. That is a short. This component is shorted because I'm getting the same reading when I put my probes together. 0.5.6, right? When I measure that, I'm getting 0.5.6. Same bloody reading. So this component is shorted out. Even if there's an inductor across it, there should be at least 0.1, 0.2 difference. So this component appears to be shorted. Right there. So I'm going to pull that. I'm going to see if I can desolder that, because we have now found something that alarm bells are ringing. Bear with me, I've got to warm up my soldering iron. I'm going to have to bring this up to 400 degrees Celsius because up to maximum, because it's on a heat sink and it's going to be hard to get it out. Where's my flux? Where's my flux gone? There you are. See. Now, getting this thing out is going to be a trick. I'll tell you why. Because it's bolted on a heatsink, right? And I can't get to the screw. So I'm probably going to have to remove the entire freaking transistor and the heatsink. So let me just have a quick look at that a minute. So the heatsink glued to the board. Right, I'm going to unsolder the. I'm going to have to unsolder these. Where's my pet screwdriver? Where's my? Right, this thing which is, oh, let me zoom out a bit. I've to unsolder that, which is, yeah, so it's going to take a lot of heat to get this out. Right, so let's put plenty of flux on there. Don't want to burn myself. Put plenty of flux on here. And on here. Now I'm going to drown this in flux. My hand, I can't keep I'm squeezing this. A lot of flux. Right, plenty of flux, because it's going to be hard enough to get that thing out. Right, we're at 400 degrees Celsius. I'm going to unsolder the try to. Let me get, where's my, I can't see what I'm doing. Get my solder sucker on it. Where's my damn, oh, it's over here. Oh, I missed. Damn. Missed again. Are you still on? Soldering iron, yeah. Soldering iron still on. I can't keep my hands still. I'm shaky because I'm old. I'm sick always. Freaking heck. Are you still on soldering iron? Warm this, melt this sucker up. Oh, yeah. I'm not making any progress. Do you know why? They put that horrible high melt solder alloy solder on it, so I'm going to have to put some of my lower lead based low melt solder on here, because I can't get this off without it. Do all three of these. I've seen so many people that don't know how to solder, you know. They put the solder on the soldering iron, then they go and do a job. That is the wrong way to do it. You put the solder on the soldering iron and the component at the same time, so you get flux on both parts. Otherwise you end up with a dry joint. I'm not talking about the other types of, yeah. Right, let's see if I can get this out now. It's that freaking horrible alloy based. There we go. I think it's coming out now. I think so. Yeah, I can see a bit more of it now. I need to get my solder sucker ready. So it's going to be tricky to get a component for this, probably. Or maybe I can find equivalent. I don't know if it's just a MOSFET. It's a low voltage side, so it's so hard to see, and I can't look at my computer screen because it's delayed. There's a lag of about quite a few seconds. I'm trying to get straight down on it. Let me just tilt this back a bit, because I need to I need to have my sucker straight up and down. I can't do that with the phone in the way. Some more flux on it. Hold on a minute. I think this flux is about to expire. I haven't had it 5 minutes. Mind you, I don't do many of these types of things anymore. Just helping a neighbour out. We try to anyway. Hang on, where's my solder sucker? Get it ready. Want it straight up and down. Otherwise you don't get suction. You can't suck solder, it's lead or whatever. Hard to suck metal up. Oh damn it, it bounced then, it didn't get in there. Too much heat can damage semiconductors, but it's attached to a heatsink, so it'll be fine. We just don't want to do it for more than, you're not supposed to do it for more than 10 seconds. I'm going to have to use my braid to clean some of this off, I think. I'm not getting a lot of it off. Alright, where's my desolder braid? Oh, hang on a minute. Oh, my leg can't move. My leg's gone to sleep now. So I've got this stuff. Just to give you some idea how awkward this is. My finger, oh, that's hot. Found the other end of it. Ah, there we go. Right. Right, some of this desolder braid. Turn my meter off, I think. Get some more room in here. Right, so my I've got some flip. What the hell? I've got hairs everywhere. Put some of this flux on here. Oh. This is freaking awkward. I'm trying to film it and it's awkward because I've got a camera right in my face. And trying to film this, yeah. Right, come on, suck that solder up. Oh, it's hot. I'm trying to do a Chinese impersonation, I can't do it. Come on, suck it up. Suck up that solder. Right, let's check, see where we are. Doesn't look like I've got much up there. My God. Oh, if I can just get that. Oh, the holes on one side look clear, but maybe. I'm going to trim that. I'll trim that bit off there. Start with a fresh bit. You know, it's surprising, you know, I used to do repairs years ago, how ungrateful some people were. They thought that it was like playing football or something, that you had fun, that you enjoyed repairing stuff. Trust me, it's no fun. It's frigging hard work. You've got to use your brain cells to figure out what's wrong. It's like you've got to be Columbo Mark II. You've got to be frigging Columbo Mark II. And you've got to have the patience. And let's face it, nobody's got any patience anymore. People can't even watch a video for more than 2 minutes. Most people nowadays would go, I'm not fixing that. I'd get bored. Oh yeah. Just want to get this damn solder off these legs. Pushing the pin through the hole to making a hole rather. Come on, if I can get this damn thing out. Don't you stick to that. I don't know. Now, it looks like I got most of the solder off. Now, what you do is when you got to this point, you, when you think you've got most of the solder off, you have to try to move the leg. And it moves, look. That leg moves. So that's free. What about this one? No, that leg's not free. That one's not free either. So we've got this leg free. That one's no longer attached to the circuit board. Some more flux. I've got 2 more frigging legs I can't quite get off. Some more flux. My solder wick, desolder wick. Freaking wires in the way, I can't move my soldering iron. We're nearly there. I'm trying to reach around my phone to do this. Normally I would not be constricted like this, but because I'm doing this on live stream, I have to suffer. Is that leg free yet? Nope. Is that one free yet? Nope. Let's try the sucker again. Where are you gone? I'm trying not to go and touch the leg that's already free. I don't want to mess that one up. missed. This is not working. In between doing, oh, that looks a bit better actually. I'm nearly there. So putting this flux on also helps to cool it over as well, by the way. So, oops, I keep doing that. I keep catching this cable with my flux. Oh, you know that sticky gooey stuff I was talking about in the video before this one? I think I know what it is. I think it's that flux. I think I went and caught it on something on it. I thought it was marmalade or treacle or something. It wasn't. It was freaking flux. Oh. Hang on. I need to put some more on here too. Oop, there we are. This braid doesn't come with flux impregnated, which is annoying. It should have some in there. Can't get to. I don't want to be. Them legs stick up and they're making it impossible to get to it. Them legs sticking right out. Right, well, have we got it now? Ah. Looks like that pin at the top is clear. Middle one's not. We're not far off. I've never had such a problem taking these things out before. You know what it is? It's that alloy solder. It's horrible stuff. They don't use lead-based solder anymore. They use alloy or based solder, and it's horrible. It's very dry when you heat it up. It's like stuck to it now. Let's try something now. Is that pin going? Oh! Touched that braid with my back of my hand. It's hot. How are you going to move? That leg was free. I think it still is. Yes, it's still free. Is that one free? Oh. I haven't even got the picking heatsink out yet. Oh God, this is going to be a nightmare. No, that's not free yet. I am getting a bit frustrated. The middle one's still not free. You know what? I'm going to attempt to let's just wet the heatsink pin and see if we can get this heatsink desoldered. Then I can pull the whole thing out. Some lead solder on it. Sometimes a big blob is better than a little blob. You know why? Because you get suction then. You get the desired result in extracting the whole thing. Right, let's see if this will work with my solder sucker. Oh, I wasn't ready to push the button. Right, get my solder sucker right, get it nice and hot. Get it really hot, because it's on a heatsink, so I'm not worried about heating this up too much. Get it nice and hot, and then look at that. That's basically cleared. Yeah, where's the hole? Can you see through it? Oh. A bit more on that one. I'm only heating the pin now. Right, let's do the other end. Get this really, really hot. It's on the. It goes to the heatsink, so I'm not worried about damaging any component because it's not on a component. Get it really, really hot. I'm at 400 degrees Celsius. Get my solder sucker right over it. Did I get it all? No. Oh, look at that. I've got solder coming out the end of it. Look at that. God. Hang on, I'm gonna clean my sucker now. Sort of something nasty there. Just a minute. You know what? I think that's going to come out. We're not far off. Some more flux. I might use my wick on it. Whoa, I think we're going to get out now. I think it's going to come out. I think it will. Hang on, my solder sucker's coming apart. Unscrewed it. Oh, Right. I think that if it's just that middle pin, right, that's holding me back. Now another trick you can do is to heat the pin up and then push it, get it loose, and then push it quickly. I think it might come out actually. Let's just see if we can get this heatsink to move. This heatsink's warm now. Hang on a minute. What's this one? Well, let's wiggle it. It's a heatsink's bloody hot now. Let's wiggle it. Let's see if we can get this to move. How many pins are there on that thing? So I am lifting it up to right. If I push down, if I push that heatsink, oh, it's glued as well, isn't it? Right, freaking glue everywhere. Right, that's that side. Oh, great. Great. Bloody resistors are in the way. I can't get to that one easy. Hang on. Turn it around. I'm right handy, that's why I had to turn it around. These resistors are actually right in the way. They don't make this stuff to repair, you know. They don't make it serviceable anymore. Just can't. I think I might be able to break that loose now anyway, if I can just get that. Turn it round again. If I heat up that pin, and the middle pin, it's just the middle pin that's stuck on here. It's moving, look. I think that pin's lower than that one now. Let's see if we've got a gap now. Have we got a Oh yes, we have a gap. I can put my fingernail under it now. Okay, screwdriver time. Put my screwdriver underneath there. Oops. Actually no, nail file would be better. It won't, it's a lot thinner. I can get it right underneath. Stick my nail file underneath there. And I can twist while I gently, because I don't want to break the legs off the component obviously, I want to test it. So if I just gently twist my nail file, warm that up, warm up the transistor middle leg, because that's still attached to slightly. Yeah, it's moving. I can feel it. It's giving. It's giving. It's giving it. Make sure that's not stuck. It's coming out. I can feel it. My nail file is slowly moving. Yeah, see it moving? We're nearly there. Doing it back and forth. Right. See how much of a gap there is there now, look. Now I'll do the other side. So that pin, is still, trying not to burn myself right now, because that heatsink's getting warm. Where is it? I lost it. Where is it? Ah, there you are. Yeah, I think this pin's still attached slightly. This one here. Oh, it's come out now. Right. Where are we? I've lost it now. Where are we? Oh, here. Got ya. It's popped out. We're free. We're free. Zoom out. Middle leg. I think my middle leg's still attached slightly. What was that one? Can't be. Oh, it might be a blob of solder on the end of the leg. Sometimes that's what holds you up. Oh, it's the glue. It's a freaking glue. It's that that's holding me up. Freaking bloody glue. Look, that glue there. That's what, that glue is what's holding me up then. So got the thing out. What a challenge. That's just to get one frigging MOSFET out, or transistor, whatever it is. I think it might be a MOSFET, but I would say that's probably what the culprit is. Right, let's just check it now without it in circuit and see what happens. I'm just going to back my camera out a bit. moving all this stuff out of the way. Right, so that was in that way around, yeah, I think. Yeah. And I was checking it upside down, and I had a short circuit between these two outside, well, easy, these two outside pins. This glue is, you know what I've just had a thought of? They sometimes use this glue stuff, right? And it becomes conductive over time. We've seen this happen many times. Putting glue over the gate and the source and the drain like that is extremely stupid, because if it goes conductive, it will short the gate out and it will destroy the component if it becomes conductive with age. I know we've seen that happen. Shango 066 has come across that in TVs where glue has become conductive and it has destroyed electronic components. Now I'm going to get this damn glue up here. Oh, leave it. Let's check it again first, and then I'll get it off there. I'm going to use some acetone to melt that stuff. Right, so my meter, if I can get it on. I'm going to turn it around because it's easy for me to see what I'm doing. We haven't got a short now. Oh, my meter does work. Could it be the glue that's leaking? Ah, this is so freaking light now. It's moving. Okay, good. If there's no short anymore, but that means we've got a problem still somewhere else. Could be a diode shorted. Could be a diode that's short circuited. Or we might have cleared the fault. I'll have to find out. Now if we go back to diode mode. Diode mode. Okay, 0.429. I've got nothing on this side. I wonder if this is a. I wonder if this is a. Two diodes back to back. Can't be. It might be. 0.430 on this side. Let's check over here. Nothing. Reverse. I think I already did that though. So well, it's definitely not shorted now. So what? Oh, that was weird. Oh well. I don't know if this is a MOSFET or a transistor yet. I have no idea. I haven't looked it up. I haven't. It doesn't seem to be giving any bad readings. If it's two diodes back to back, which sometimes you get that, but because the circuit board's labelled in Chinese, I don't know what the hell it is, because the circuit board, we'll be able to see it better now if I zoom right in. Hang on a minute, I can't do it with one hand. Well, if you look at that symbol, oh, hang on a minute, maybe it isn't Chinese, maybe it is just, oh, it looks Chinese. It's weird looking diode. No, it is Chinese, it's not a diode symbol. This is what annoys me, when you've got diode symbols and crossed with Chinese languages, it causes a hell of a lot of confusion because you don't know what the hell you're looking at. Those symbols right down there. Hang on. Where are we? I lost where I am now. Shit. Oh, can't get it. Those symbols. Ah. I looked at the wrong one before. I need to clean that up with some acetone. Will take the writing off maybe. Or I wouldn't have alcohol. I'll have to use some up because I can't read what that says. Just a minute. Let me find a cotton bud or something. Oh, found one. I'll do. Oh my God! This bottle had a little bit of alcohol in it. It's gone. It's evaporated. The freaking bottle's it's leaked out of the bottle. What? I've got no alcohol left. You know what that means? Do you know what that means? I've got to use freaking acetone. I don't like using acetone. It might take the writing off. I'm not bothered right now. I just want to. I just want to get that gunk off there. I'll have to be quick. Let's get it onto the camera so we can see. Oh, my soldering iron is baking. Hang on a minute. It's cooking. Need to turn it off. Just a minute. It ruins my tip. I've turned it off now, but it's still cooking. It's oxidizing all my tip. Hang on a minute. Come on out. Oh, stupid thing. Oh, what have I done? Oh, my phone went all blurry. My phone's dried up again. More water. That's better. I don't want my tip oxidized because it won't, nothing sticks to it. You know when you're soldering, if you've got an oxidized tip, it's like, you can't solder anything with it. You've got to clean it all off. Here we go again, stuff falling over. Right, so I've got the bit of alcohol. Sorry, acetone. Which should be alright because it's got varnish on here. I just want to clean this crap off here. As long as I'm quick, it'll be alright. I don't want to melt the vat. I don't want to melt everything. That's better. I can see that better now. If I get it under the camera, there. That looks better. Better. My grandma used to tell me off for not talking properly. Right, let's check this other one. This other right in here. I don't want to rub the writing off, obviously. I think they use varnish nowadays that's acetone proof. It's like a resin or something. Okay, so why have we got a short down here that's 0.1? Could be this coil. Transformer. Is the transformer shorted out? Could be. These things do fail sometimes. But we should not have something that much of a dead short. It's quite possible that this transformer has failed because it's reading so frigging low. Right. Get my meter, put that over there. You only have to do it is to check it on an inductance setting. Let me zoom out a bit so you can see my meter. I'm trying to get that in. Right. You see, look, we got 0.5, right? Across where that transistor goes. And now look how I shot my meter together. See? My meter's shorted together now, look. 0.0. Oh, it's not connecting right. What? Just a minute. Where's my meter? Oh, these wires. No. Just a minute. Right. Right, 0.5.6. We have a short with my two probes together, right? We're getting the same freaking reading across here, which means is not good. That is not good. I would say that this transformer is shorted out because we should get at least 0.1 above it, like 0.7, 0.7. We have a short circuit somewhere. We should have 0.1 or something. If you measure coils and on generators, for example, you normally get 0.1 or 0.2, no, you get 0.6 or something silly. That goes to this winding. Let's see, is there a capacitor across there? Now I've got a resistor here. Let's check that. Is that across it? That was just as 8.6, so that's not shorted. It wouldn't surprise me if that transformer's gone bad, you know. There's a bit of discoloration on it, could be varnish though, it's a bit yellowish. It's got... That seems too low. Especially for a transformer this big. It's a big transformer. It's not like it had a tiny little one-turn coil. And if you're measuring something with like one turn of a wire, just one wrap or two wraps, you would expect to get something like, well, a short circuit, right? But this is quite a big transformer, so you should get we should get, I mean, let's check some of the other windings on here, right? Check between there and here, nothing. There, nothing. But that's across the transistor. These two, right? 0.5. Right. What about the other windings? There's 4 wires coming out of here, look. 4 wires. I'll say these two maybe. Ah, no, those two are connected, bridge there. They are meant to be. Right, so these two are for that, so it must be these two. No, they're not connected to anything. We've got windings on the other side. These are for the higher. They're driven by this transformer, right? This coil, this transistor or MOSFET, right? This MOSFET here drives this side of the transformer. So this side is the output, right? The output should be higher. It shouldn't be that low. This is not looking good. So that's the number on the transformer. Maybe somebody else can look it up, YF773, because I don't have any access to those databases. When I used to be self-employed, I had some access, but I suppose it might be on the internet. But no, but this is all proprietary stuff, so they're not going to put it available. It's not going to be available. Yamaha is closed shop. Closed shop. Nothing to see. Move along, move along. Closed shop. Generators are a different matter. You can usually find stuff out about them, but some of this stuff is just, unless you've got a business account, they won't let you have access to the information. You know what I mean? I know that because I used to be self-employed, and we used to have a business account. And the reason for that is they don't want every Tom, Dick and Harry coming along and hijacking their game. So yeah, I'm not being very optimistic right now. It's looking like this transformer's bad. I have repaired transformers before, but you know what? This thing is soaked in resin. It's soaked in resin and varnish, whatever. You'd have a job getting into that. And it's not worth it. It's got resin dripping out of its freaking eyeballs. You can see it all over everything. It's like they've dipped the whole bloody board, actually. It's like they've dipped the whole thing in something. I remember in the old days, back in the old... they used to dip stuff in tar years ago. They used to... The old flyback transformers for TVs used to be dipped in wax. You know, they'd put them in this boiling wax thing and dip them, and they'd all be... When they cool down, they'd suck all the wax inside, and impregnable. But wax was easy to pick at, you know, you could get into it, but not with this freaking stuff. It's rock hard, it's hard resin stuff. Dipped it in. And because I've checked most of this stuff and I can't find anything, there's nothing blown up on it, there's nothing. The only thing I found that it was shorted was this thing here. I thought it was this component, but it's not. That was really hardly stuck. That was really stuck to the board. They'd even put glue or something on these legs to stick it to the... I don't know if you can see this, but if I zoom right in to bottom of them transistor legs, it's pulled that resin off the board, look. There's like little discs. That's freaking resin drops. It literally pulled it off the board when I lifted it out. It's resin. Like a blob of glue. Oh, it's a ferrite bead. That's what it is. They put ferrite beads on these. These have got ferrite beads on the legs to stop transients. I'm not talking about homeless people. Transients as in electromagnetic pulses that you don't want on the data lines and power supply lines. Those are little ferrite beads. I thought it was some resin, but it's not. They've actually stuck resin on there. That's what's holding it all on. That's why they put the glue on there, to hold these ferrite beads in place. Now, these ferrite beads are magnetic. So, if I get my magnet, my magnet sticks to the ferrite beads. Well, it's not sticking to the heatsink. The heatsink's aluminium, look. Won't stick. Watch. Oop, dropped it. See, it won't stick to that. Won't stick to these legs either, look. No, them, only the ferrite beads. Or the screw. Right. I'm done. I'm going. Thanks for watching. I didn't make any progress apart from getting that thing out of there. That was a waste of time, wasn't it? I wasted how many hours of my life doing things like this and fixing things or trying to fix things, and 9 times out of 10, or not 9 times out of 10, probably 5 times out of 10 you would spend all day trying to fix something and end up wasting your entire day on something that's just not worth it, right? And then you get an ungrateful sod who comes along, it's probably just a loose wire or something, and they don't pay you. Oh, how much is the repair bill? Oh, it's 35 quid or something, 40 quid. And that's too much, I can't afford it. I've just spent 6 hours of my life trying to fix your freaking, yeah, the ingratitude you get nowadays. Well, back in the 80s and 90s. This is why so many repair shops have just given it up now. It's not worth throwing away your life on something that people aren't grateful for. Now people are trying to figure out how to fix stuff themselves because no one's around anymore to fix stuff, and they're starting to figure out how hard it is. It's not easy. It's hard work. Anyway, bye for now.